Okay, I'm going to talk in this video a little bit about the p-value and interpreting it because it can be so much fun and everybody's favorite. Probably what you're feeling like at this point is this, but p-values are really important. It's one thing to be able to make a conclusion and say, since the p-value is less than alpha, blah, 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 but to really know and understand what the p-value is telling you can be really helpful on other types of problems and on some of those harder fear response questions that like to come up every now and then. So this is our basic interpretation of a p-value, kind of more general. Assuming the null hypothesis is true, our p-value is the probability of getting what we got in the sample or something more extreme by chance variation. So I'm going to just kind of draw a little picture showing you what I mean by this. So when we do a hypothesis test, we are always starting out assuming that our null hypothesis is true. So let's say our null hypothesis is that mu equals 50. So that means when we do this hypothesis test, assuming our conditions pass, we have this normal model in our minds where the true mean is 50. Okay? And we're trying to show, let's say, that the mean is greater than 50. So what we do is we take a sample, and from that sample data we get a mean and a standard deviation. So let's say that in our sample data we got a mean of 62. What we're finding when we do a p-value is we're finding, well, what's the probability of getting a mean of 62? If the true mean were 50, what's the chance I would get a sample mean of 62 or higher just by chance? And that is what I'm finding when I find a p-value. Which is why if we get a very small p-value, okay, then we're saying that seems really unlikely. It's less than 5% likely to happen if the true mean were 50. So that tells us a couple different things. It tells us that maybe the true mean wasn't 50. If we got such a high value just by chance, then maybe that true mean wasn't actually 50, maybe it's higher than that. We're not saying it's 62, we're just saying we have evidence that maybe it's higher because we just randomly got this mean of 62. The other thing it could potentially tell us is that our sample wasn't actually random, that there's something going on in our sampling process or in our actual group of people. So maybe the true mean of all random samples was 50, but we got this sample that wasn't actually random, and that's why it ended up being higher. So that is kind of your basic interpretation of a p-value and what it means. So this was one of our examples. I think this is one of the homework problems one night. It says, during 1 hour, the mean number of fluid ounces of 4 randomly selected bottles was 12.05. And the standard deviation was 0.085. And on part B, this is part B of that problem, we were trying to determine, do we have evidence that the standard deviation is greater than 0.05? Well, we have no frame of reference on what the shape of the population, like all the standard deviations would look like, or even all of the sample standard deviations would look like. All we know is what we're given. So this right here is giving us kind of a sampling distribution, so to speak. So they ran a whole bunch of samples under the assumption that the mean was 12.1 and the standard deviation was 0.05. So that was our null hypothesis. So all of these simulations were run under those assumptions, and this is kind of our sampling distribution, all of the standard deviations we got from all of those samples. And using that, we're going to determine, do we have evidence that this sample standard deviation is out of the ordinary? If I want to find evidence, I'm going to need a p-value. The p-value is probability assuming the null is true, which is what the sampling distribution was under the assumption of, assuming the null is true. P-value is the probability of getting what we got in our sample, which was 0.085, or more extreme. So if I look at my sampling distribution, 0.085 is about right here. And more extreme, because we're testing, is the standard deviation greater? Right, we would go that way, greater. So if I just count, there are 12 dots out of, it said 300 samples, which is 0.04. And because that p-value is less than alpha of 0.05, we would say we reject the null. We have evidence that the standard deviation of the amount of juice dispensed is greater than 0.05 because we got this sample standard deviation that was much higher than what we would normally expect. So that is just a little example of using p-value to do a little bit harder types of problems.